Hello there, welcome to this video tutorial on how to construct a molecule in Avogadro. My name is Spencer Carboni and I'm a member of Dr. Simpson's lab at St. Bonaventure University. Great, so let's get started. So say that we have a molecule that we want to create the structure of and then import into Turbomol. So Turbomol is our quantum chem program that we use here. So the first thing that you would want to do is figure out the structure of your molecule. So in this case, we're going to do some pesticide research. So we're going to pull up a test molecule called acephate, A-C-E-P-H-A-T-E. Search it up, and then you can find the structure of it, usually in Google Images off of Sigma Aldrich or a similar site. So here's the structure that we're going for. So we can manually construct this, or we can download a 2D molecule file and then optimize it. So I'm going to go with the latter route because it's a little bit faster. So you would type in acephate structure, scroll and look for ChemSpider or PubChem. It's also a good resource. PubChem. Okay, boom. Now we can open up the molecule and we can download its 2D geometry right here. So you can click download, and then SDF is a pretty good file type. We can save the file. So let's just put it onto desktop. And then we can title it with our file's name, acephate test. Save the file. And now we can put this file into this program called Avogadro. So what Avogadro does is it's an open source tool that can let you visualize and build molecules. So we're going to click, so we're first going to open up Avogadro, like that. You're going to get this screen. So this is the build screen. So you can drag molecules around and you can construct them yourself, like that. So we'll go over that in a future tutorial. But right now I'm going to show you guys how to open up the file and optimize it. So we're just going to click open, navigate to our file, acephate test, open. Yikes. Now we're going to click yes to build the rough geometry. So now Avogadro is going to do its best. It's going to do its best to guesstimate how the molecule should look. You can move it around. So if you press your scroll wheel down, you get to this rotate mode, and if you move your mouse up and down, you zoom in and out. You can use the right click to pan. You can use your left click to rotate like this to get different views of the molecule. So once it's in, you want to make sure that the basic general form, so your like RNS considerations, your like E and Z, you need to make sure that it goes along with how the molecule should look. So go back to your reference sheet, your reference file for the molecule. And you want to make sure that what you have in Avogadro mirrors this. So I believe it does. Let's rotate it around, give it a good look. Looks good to me. So now we want to do a basic geometry optimization before we import it into our next tool. So we're going to click on this E right here, the auto optimization tool. Start it, then let it do its thing for a little bit. You can let this run. You should stop it once it's in a stable state, or once this DE goes to 0. Bless you. Let's let it run a little bit longer. Then we can jump into our next step. That should be about good. I don't see a lot of atomic movements. So now we click stop, and then we save our 3D optimized file. So we click File, Save As, you leave it as this default, and then acephate test 3D or some other name so that you can differentiate it from the 2D unoptimized file. So save that, and then hop over to
What file type?
what file type? Whatever the default is in the Save As field. So you click Save As, and you can choose any of these. CML works well, but I usually just leave it as common molecule formats and just let it sort it out. Got it? Nice. Okay. Okay, so now we're going to click on Extensions and then Mol Pro. And so this will give us the Cartesian coordinates of all of our atoms in this molecule. So you scroll down a little bit, you see this 20 right here? That's the total atom count. And then you highlight this, so you drag from 20 down until you hit your last atom. Right-click, copy, or click Control-C. And now you have the atomic coordinates in a basic optimization copied. So now we go into our next tool, which is called Cygwin. Cygwin 64 terminal. So make sure that you have this tool installed and that you're connected into your server before you jump into this step. So what Cygwin is it's how we interface between a Windows PC and our Linux server that does the calculations for us. So our first step is to sign in. So you would use this SSH and then your username at your address of your institution. So in our case, at St. Bonaventure University, it's at Priestley, priestley.sbu.edu with your username in front. Click Enter, and then put in your password. Enter, and now you're inside of Cygwin. So now you have access to the Linux server that's on campus. So now what you do is you make a folder where you're going to store all of your different molecule files as they go. So the command to do that is makedir, so mkdir, space, and then the title of your folder that you want. So we can see what's currently in our folder with the command ls. So type ls, click enter, and so now we have 3 different folders. If we want to make a new folder, we would type mkdir space test, enter, and then ls will show us that we now have a folder called test. So to change into that folder, we use the command cd, and then we jump into that folder. So cd test, enter. And you see now that test shows up on the screen. If you want to make sure that you're in the right place, you can use the command pwd, enter, to figure out where you are. So we're currently in home, username, comma test. So for each molecule that you're going to work with, you first make a new folder for this molecule. So you would type makedir, mkdir, space, and then your molecule name. So we're going to do acephate, because this is a test, we're going to call it acephate test. Enter, then you jump into that directory, ACE. So a fast shortcut, so instead of typing out acephate test, you can type as much of the name to make it unique, and then click the tab key. So the tab key, that will jump and auto-populate the rest of the name, which is good so that you don't accidentally put something in the wrong place or misspell a directory. So that's not good. So we're going to jump into our directory, and now we're going to use a text editor called VI. So we're going to type VI space X. So this will make a new text input with a file called X. So we click enter, and now we're inside of a blank kind of notepad type file. So our next step is to click on the letter I, which puts it into insert mode, and then you right click on the screen, and you click paste. So that will put our atomic information into the screen.
I specify you can't use Control-V or anything.
Yeah, you can't use Control-V or Control-C, because those actually do different things within Cygwin than they do on your regular PC. So you need to do the whole right-click, paste. Then you hold Control, you click C to take it out of insert mode, and now you click on colon, like that, and then WQ. So that will write the file with W, quit the file out with Q. Enter. Okay, so now you have a file called X with your atomic coordinates. Now, to work with that file, our first step is to click TX. So that will run a script that will give us some more files. So let's type ls, see what's in there. We have just the file X. Now we type TX, enter. So that will give us a new file. So I always like to click ls after running any scripts like this, just to make sure that you have the right files. So we have a file called coord, C-O-O-R-D, in there. Is it working for you, John? Not yet? Oh, Control C.
Yeah.
And then Shift, colon, WQ.
There we go.
There we go. Now type TX. And then enter, and then ls.
All right.
Okay, so now we have a file called coord. So now what we're going to do is we're going to run the program called define. So this is within Turbomol. So this will get us our, this will help get us our ground state of our molecule. We type define, click enter. And so now you have a lot of information pop on the screen. Click enter twice, so enter, enter. And now you're going to specify the molecular geometry. So you type the letter A, space COORD. That will populate our 20 atoms into the define program. So A space COORD, enter. You see the atoms right here is now 20. Make sure it's still recording. I think it is. Okay. So now what you do is you give it the star. So you go Shift 8, that'll give you the star, enter. And now it will give you a pop-up that says, do you want to use internal coordinates? We type no. Make sure to type no, because if you just click enter, you're going to need to do it all over again. So type no, enter. So now you're within the screen where we assign atomic bases sets. So this will be specific to whatever kind of research that you're doing. So check with your research professor before executing this. In this case, for this pesticide project, we're going to type in B space all space DEF2, lowercase DEF2, dash, and then capital TZVP. So this is a specific basis set. It's the second definition of the triple zeta valence polarization. You can learn a lot more about that online if you search up that keyword there. So you type in that, you click enter, and we should see up here that it says def2 tzvp, and it worked a bunch of magic to bring us to this state. So now we're going to jump out of the screen. We're going to type Shift 8 again to terminate the section, write the data, enter. So now we're going to configure this specific instance of define. So this is our initial running of the file. So we're going to get a file that we can run in other software. So we're going to type EHT. So these are our basic steps. So whenever we run a file in define, we want to do these steps, and you can add other steps to it if you want more focus. So we type EHT, click enter, enter a bunch of times, enter, 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 enter. Okay. So now we see all of these different commands. So I usually start with SCF, enter, and then type iter, I-T-E-R. So we're going to let our file run for more iterations than it started with. So it starts with 30. We type in 100, click enter, enter. So now it's at 100. So we can check our work, SCF, iter, it should say 100 right there. Okay, so we're back to our home screen. Now we're going to type in DFT. So we're going to turn on density functional theory, DFT, DFT, ON, enter, enter. That'll bring us back home again. Now we want to turn on RI, RI, enter, type ON, enter. Now RI is on. Click enter again. Now you're back home. So that's it for this screen. So now we click Shift 8 once again. So now we're going to click Enter, and now define is done. Good job. So now we're going to jump into what's called Cosmoprep. So that's our next step within this. So you type in Cosmo, tab, that will get you Cosmoprep. So I'll click Enter. That will put you into our next program called Cosmoprep. So now you click Enter a bunch of times. I think it's 11 times. Enter, 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 until you get to this screen. So on this screen, we type in, so we're going to enter in our atomic radii. So we type the letter R, space, all, space, O, enter. But we're missing an atom there. So what usually is up is that the atom phosphorus is missing. So if we go back to our Avogadro file, you can see that phosphorus right there. And that phosphorus is causing us trouble because it doesn't exist within the basis set, so we need to assign it ourselves. So to do that, we type in the letter R, space, and then we do the double apostrophe. So above the single apostrophe, right to the left of your Enter key. Then we type P, got to be lowercase, double apostrophe B. So R, P, B, just like that. Then you type Enter, and see it magically fix itself, which is good. So now we click Shift 8 to jump out of this screen. Now that we have all 20 of our atoms expressed with radius. So 20 atoms with radius is here. So we click Shift 8, exit out of the menu. So now we assign an output file. So this CCF file is what we're going to pull down later in order to do further calculations in Cosmotherm or another quantum chem software. So we're going to title this file something that you can remember. I usually keep it the same as our directory title. So acephate test.ccf for this one. But you would name it whatever your molecule is, .ccf. Enter, enter. Okay, good job. So now we're back to our home screen in Cygwin. We can see our new files. We have our files control, coord, basis. Those were created in define and Cosmoprep. Okay. So now what we're going to do is copy in what's called a subscript file. So this file should be provided to you by your research professor for the first time. Then once you have it within a folder, you know its location, you can then copy that same file every time. So the command of how to copy a file is you type cp. John, you might have it. Okay. So you type cp, and then you put in the location of the file. So in this case, it's in. I'll actually find it real quick. Okay, so it's within this directory here. Your research professor will show you where it is. So I'll jump back into our test folder. Okay, so now we're going to type cp, and then the address of our file's location. So in this case, it's this. Home, my username. Nope, it's this one. Home, my username, turbo, and then the main folder. Paste. Turbo acephate slash, and the file is called subscript. So sub, click tab to complete the file name, and then you click space, and then dot slash. So the dot slash right here refers to your current working directory. So that's acephate test. So it will copy the file in home, username, turbo, acephate, the file called subscript, into your home directory. So now you click enter. ls shows you what's in there, and you have subscript right there. Boom. So now what we're going to do is we're going to open up this subscript file. So we type vi subscript. So you type vi subscript, enter. Now this is your file that will that will execute the job. So up here, you don't need to change any of these parameters except for your name. So since I pulled this from regular acephate, we're going to change it into acephate test. So to add or change text, you click I to go into the insert field so you can change things. Now you would type test. Now you jump down. So all of this stuff right here that you see, these are just the general parameters for the job. Okay. Down here, this code right here calculates your vibrational frequency. So since this is the first time that we're running this file, we're going to uncomment all this so it will run. So this little hashtag here comments out the code. So when the computer runs it, it won't execute. So we're going to get rid of all those hashtags, just using our arrow keys to move around and our backspace. Okay, so now all that code is reactivated. And now down here, so this is a future lesson on ESCF. So ESCF is used to calculate polarizability and your anti-stropic frequency. So we're going to do that later. Don't worry about it now. You actually can't run ESCF at the same time that you're running your vibrational frequency. So that's why we're just going to stick with the vibrational frequency for now, which is this code. So once your subscript file looks like this and is ready to go, you hold Control, click C. That will take you out of the insert field. You do colon, write, quit, WQ. Enter. And now your subscript file is ready to go. So you would check LS, make sure that it's still in there. Now you would submit your subscript file. So to do that, you use a command called qsub, QSUB, space subscript, SUB, tab, script. Click enter. And now in order to check if your job has been submitted, you can use the command qstat, QSTAT, enter, which shows you that your job is running. So this R right here shows you that your job is running, which is good. So in about 2 to 8 hours, you should get a result out that you can then analyze. So say your job isn't running right. So it's been running for a few days, nothing's really going well. You can delete the job. So how you do that is you use the command QDEL space, then your job ID. So 18588. It's from that field right there. Click enter. QSTAT. And the DR means it is deleting. Okay, so make sure to use this command with caution because you can delete any job on the server. So we're trusting you with this privilege. So let's resubmit it. So QSUB, subscript, enter, QStat, and it's running again. So I think that about wraps it up for our first tutorial. Thank you for tuning in, and good luck with Cygwin.